Hello, everyone, and thank you for joining today's webinar. I am Rachel Lockwood from NXP. Today, we're joining our partner Sternum to present the topic, Bringing Security and Device-Level Insights to IoT Products with NXP's and Sternum's Technologies. Our presenters today will be Stella Orr, Security Product Manager from NXP, as well as Natalie Chuva and Leon Granote, co-founders of Sternum. Natalie is the CEO, Leon is the VP of R&D, and as of last week, also the CTO at Sternum. So thank you to each of our presenters for preparing and for joining us today. We will have a live Q&A session at the end of the presentation. So as we're going through this material, please enter any questions that you may have in the question box of your GoToWebinar user interface. Once again, thanks to everyone for joining the webinar. I will now hand the microphone over to Stella to kick off the material.
Thank you, Rachel. Hello, everyone. I'm Stella Orr, the Security Product Manager of NXP. So today, we are going to go through these topics here. First of all, I will go through some key elements that we need in a secure solutions. Then I will highlight some security feature of a NXP microcontroller in our software enablements. NXP provides you a secure platform for your applications development. After that, we will have Natalie to present their runtime security and remote device observability solutions. Lastly, Leon will run a demo on a NXP LPC5500 device to show how Sternum's technology can catch the exploitation of an application software and how it can be fixed right away without deploying patches. Also, you will see how Sternum provides you the visibility of the device. And at the end of the last 10 minutes of this webinar, we will have a Q&A section. So how can we build a secure solutions with NXP device? So here are some key elements of a secure platform. First of all, you will need a secure ROM bootloader. It is an unimmutable bootloader from a processor. It prevents unauthorized code from being programmed or executed from the processor. It also ensures the integrity of the boot up image. After that, many applications, it requires a second secure bootloader. It can be used for application code verification, integrity check. It is also need for future update, for example, the over-the-air update. And secure key storage. It is the secure area to protect secrets and sensitive information, for example, encryption keys. And we also need device authentications, image encryptions, and verification. So these are used for IP protection and counterfeit detection. Tamper resistance is any methods we try to react to a tamper event. For example, we can have a secure package on our device, on our processor. We can also have some countermeasurement on the software, especially on the cryptographic algorithms to prevent some attack happen. Some of our NXP device, we have tampered sensors, which can provide a active response to the attack. For example, to erase any sensitive information or secrets storing in the port immediately. And lastly, we also concerned about we also have some concern about the industrial standards that we may need to conform. So, for example, it could be common criteria, FIPS, PSA certificate, and also the CSIP. So we may also need to think about is the processor is designed to conform to these standards. So security is a big concern in many industries. NXP has been offering many microcontrollers and microprocessor with security enabled features. Since our demo today is based on a LPC5500 device, let's have a look on the security feature of this MCU. So you can see from the block diagram, I highlight some security feature in this MCU. And let me go through some of these one by one. So the secure bootloader, it is the major component to ensure the root of trust of a product. Secure bootloader is designed in the ROM of the MCU. It is immutable. When the MCU boots up, the secure bootloader performs application code verification and integrity check with RSA or SHA algorithm. And unauthorized code is not allowed to be loaded and executed in the MCU. With the right design of a second bootloader, secure OTA, secure over-the-air update can be achieved through wireless connection. Trust zone, it is used for code isolations. It creates a boundary to separate the secure and non-secure worlds with dedicated memory allocations. So application code with user interface such as touchscreen, LCD, audio output are usually considered as unsecure code. It should be stored and executed in the memory in the unsecure world. On the other hand, OS, operating system, or kernel, or some security-related peripherals are considered to be put in the secure world. Trust zone forbids the code from an unsecure world accessing the memory in the secure world. PUF, the physical uncountable functions, is a dedicated SRAM used the dedicated RAM as the silicon fingerprint, just like the human fingerprint. Each device has its unique fingerprint. We can use the PUF to generate, store, or to reconstruct keys. Cryptographic blocks, these are the essential blocks for security device. To protect your valuable access, you may want to protect your software IP and your secrets by encryption and digital signature. The crypto blocks here consist of AES, SHA, Casper, crypto engine, which can be used for code or secret encryption, verification, and integrity check. TRNG is the true random number generator. It provides quality random numbers for key generation. It is important to have a NIST compliant TRNG in a secure solution. Prints is used for application code protection. Application code can be encrypted or decrypted on the fly when it is written or read from the on-chip flash. It supports booting of image from prints encrypted flash regions. Secure debug authentications is a challenge and response protocol to authenticate the identity and credential of the debugger. Access rights settings can be preloaded to the MCU before it leaves the factory. The secure part of the device is non-accessible to the debugger until the debug authentication process is successfully complete. And lastly, the protect flash region. It is a secure region, store the secure boot configurations, root of trust key, custom configuration, debug port setting, and some user configuration. So the PFR is an irreversible area once the configuration has been set. So here are some major security feature that you can find from a LPC5500 processor. So we just talked about the MCU and also NXP, we provide some software enablement that help you to develop a secure solutions. So apart from the MCU, we also provide the SDK. It has some examples like the MCU boot example. It has the TFM examples. And for secure software protocols, we provide like the embed TRS, Azure RTOS TRS, Wolf SSL, embed SSL, and TRS protocol. And for the runtime library, we support multiple OS, for example, the FreeRTOS and Zephyr. For the PSA certified products, NXP continue to working on any new products like the MCU products in the market. So right now we have some device, they already got the PSA certifications like PSA level 2 and level 3 certified device. These are a set of device they got the certification approval from PSA. And since we talk about the secret keys and the IP protection, NXP also provides you a secure provisioning tools so that when you manufacture your products, you are able to generate some keys, doing some secure provisioning for your device. Okay, so as we all know, security is a big concern. NXP provides you a secure platform to develop robust products. You can build your application software on top of it to address your market requirements. However, it is almost impossible for software developers to develop an application software without vulnerabilities. Hackers look for every single opportunity to hack into your design. Memory-based vulnerabilities are especially concerning because most memory-based attacks target applications. Most application security solutions focus on identifying vulnerability in the code, then deploy patches to the device in the field. Regular patching of your products could lower the risk of your products from being attacked. However, have you ever estimated the time that you used for discovering a vulnerability and the time you used for developing and applying a secure patch to your products? It is a time-consuming process with a lot of experts, resources, and logistics involved. Moreover, it is a stressful situation. You and your team need to run against the clock because your products are now at risk. So enabling runtime security software in your products could help improving these situations. Today we have Sternum lately to introduce their runtime protection solutions and also the remote device observability solutions. So let me hand over to Natalie. Thank you.
Natalie, did you get the pop-up to share?
Hello, everyone. I'm assuming you can see my screen now. Very happy to be here. Thank you for joining. And thank you very much, Stella and NXP. This is a great way to present what we're doing together. I thought to start with just explaining a little bit about our partnership and what it means. So actually, when NXP reached out and said, you know what, security for IoT devices is really important, and what you're doing seems very interesting. We would like to see it in action. We were amazed by the security knowledge that the CTO office, Mark and Martin, brought to the discussion. And during that period of time, they've tested the Sternum solution in the most comprehensive way. They crafted attacks. They tried to break our technology. They tested our overhead. As we all know, overhead and performance are super important in the IoT space. And what they found out is that we were able to block each and every attack NXT crafted. We were able to prevent it. We were able to alert it with less than 3% overhead. And this is really the story of how Sternum became the only NXP partner that provides security, application security, software security, and deep observability into NXP products, into embedded devices and embedded systems. So this is just a background. And a little bit about myself, really in a nutshell. Started with computer science when I was 14, and that led me to becoming a reverse engineer and a cybersecurity researcher in Unit 8200, which is the Israeli NSA. From that point on, I just continued in the path of finding vulnerabilities in Linux kernel, in Android devices, in drivers, in bootloaders. That was really fascinating to me. Also developing the exploits, how to actually exploit the system, not just find a vulnerability, but take it to the next level of taking control over a device. From that point, it was clear to me that no system is safe. There are always vulnerabilities, even in the most secure systems. And I asked myself, what can we do? Because patching all vulnerabilities or finding all vulnerabilities sounds like an impossible task. This is how Sternum got to be. And this is why basically I'm talking to you today about a deterministic way of providing the benefits of XDR, of endpoint protection, of application observability into the embedded space. Sternum is already working with many leaders in the industry. Medtronic, the X Group are only a few. Some of the leaders we're working with we cannot disclose. We raised $40 million to date, Spark Capital, SquarePeg, top 10 VCs in the world. And we are really aiming to be the best IoT product. Even though we won this award, we are continuing the improvement of our platform, as we would like to really help developers, device manufacturers, to build the best products they can build in a secure way and in observed way. A few numbers, because we need to put it in some scope. So we have 127 new devices connected to the internet every second. That's more than laptops, that's more than mobile devices. And you can just imagine the amount of data these devices are generating. They can see what we are doing, temperature, video screens, and so on. They are responsible for so many things. And we got so many of them. So imagine just the challenge of understanding this data, gaining insights from this data. And just in the past 6 months, we had 1.5 billion IoT breaches. And we know that the spending on IoT security is growing and continuing to grow, and there is regulation kicking in. There is lots of efforts, lots of attempts to understand what it is to be secure. But still, we are seeing that attacks are continuing. and we're not sure we are doing such a good job securing IoT devices. It's not so simple, and we will dive in this presentation into why it's not simple, why it's not as easy as other things, and why it's important to secure them. But first we have to ask, what will happen if an IoT device will get hacked? What's in stake? And we see three major elements that contribute to this question. First, IoT devices being so widely spread and so diversified became a really attractive entry point to the enterprise network. So enterprises or your customers, you with building devices, the customers that are buying those devices puts you liable to the security of those devices because they don't want the video recorder or the security camera or the printer in the organization to become an entry point to the entire enterprise network. That's one thing why we have to remember that even if the asset itself doesn't seem like the most critical asset, we have to secure it. The second is, of course, if there is a publication about your vendor's products being vulnerable, this could lead to ransomware attacks, reputation implications, and actually many companies that suffer a security breach do not recover in the 5 years after the breach. And of course, infrastructure. IoT devices are part of our medical devices, our railway systems, our smart cities, our industrial systems. So those assets are extremely important. Even I would say the most important asset that we can think of are actually embedded systems. So we have to make sure that they are secure. Now we have to ask ourselves about the challenges and why we are falling behind. So first, we have to remember the limitations. IoT devices are not like any other server or endpoint or an application. They have limited resources. They can't really operate an agent or heavy security solutions. We have high diversity, different operating systems, different hardware. Even within NXP, there are so many different modules and products that can contribute a lot to the diversity of the application running on the hardware. We are highly dependent on supply chain, on third-party libraries, Bluetooth libraries that I'm sure caused you a few bugs in the past. No one ever used the Bluetooth library without having a crash. And this actually contributes a lot to the complexity of the security. We see that vendors are mainly relying on patching and on defenses like static analysis and things that are really passive and really the trivial things to do that do not really provide real-time protection, and also has a lot of implications that we will review. And of course, there is no on-device XDR or EDR solutions that are popular in that space. You can't buy CrowdStrike and put it on your embedded system. And the implications are really varied, but a few to mention. Manufacturers are caught in an expensive cat and mouse game with security patches. We've seen industries that a single patch can cost like $2 million to produce and to update. Your developers are in a loop of integrating patches, verifying that the patch is working well, and then rolling that into the market. And by the time the patch is being rolled, most of the vulnerabilities can already be exploited. Also, this does not provide any protection from 0 days, and some IoT devices cannot really be updated. So we spend a lot of money. We only protect ourselves from known vulnerabilities, and we do it not in a timely manner. Devices have no proactive protection from 0-day threats. So every other asset you can imagine, cloud, laptops, PCs, email, everything has real-time protection, preventing threats, preventing 0 days, identifying malwares. We don't have that in IoT devices. There are only a few companies, happy to say some of them are market leaders working with Sternum, that protects their devices at the endpoint. Third-party software vulnerabilities open the door to supply chain attacks. And I don't need to really elaborate on the past year supply chain attacks that we've seen. IoT devices are extremely vulnerable to that. And lastly, high overhead requirements force engineers to make trade-offs. I want to release fast. I don't want this software to hurt the performance of my device and so on. And when there is trade-offs, developers will always choose performance, and I encourage that. First, you need to build a device, a product that is working well. The challenge is how can we bring security that make developers not choose between the two. Now, I want to give you a glimpse into the hacker's view, what hackers think when they start attacking a device. And I took a real life example. There is an exploitation video in YouTube. So it's publicly available, hacker on the internet, downloading a publicly available exploitation of a 0-day, it was a 0-day, now a 1-day vulnerability, Stack Overflow, downloads the exploitation, finds a Cisco router, business router, connected to the internet, probably miles away from the hacker, and exploits the router through this publicly available exploitation. The router obviously did not get the patch yet, even though it's a known vulnerability. And now, hacker has full control over the device. He can disrupt service, he can move into the enterprise, he can perform a ransomware attack on Cisco, having control on many devices, and so on. And of course, he can steal IP, he can leak data. So endless possibilities. And that's a 1-day attack that we've seen on YouTube from this year. So a vulnerability at this stage is something that we keep seeing. They will not disappear. But what can we do to actually protect those devices without constantly patching them? Now I want to say a few words about observability. So what you can't see actually can hurt you. And in the IoT space, we have a lot of black box effects. We have some basic device data, like where my devices are, some fleet management, some device management, but we don't really have device level visibility once the devices are shipped. If you imagine companies like Datadog and Coralogics, they bring you visibility into every aspect of your application. Buttons that are being pushed, quality issues, performance issues, continuous monitoring on customized logs and metrics. You don't have this standardized observability or application monitoring solution to embedded systems. Everyone is building their own and have very limited, usually not real-time data with no insights. The lack of resources, including bandwidth, also means that we need some more accurate and effective solution purpose-built for the IoT. The implication is that we have no visibility into performance and security events in the field. If someone is hacking you, you don't even know about that. If someone is selling your devices in places you don't want them to be sold on, if someone is reverse engineering your IP, if your devices are crashing, it's very hard to perform remote debugging. Partial data is causing root cause analysis delay, resulting in really high time to remediate. And even more so, without having data from your products, you are lacking some essential insights to produce the next generation of your product and to take business decisions. The implications of, or let me say, the values of observability are pretty obvious in the IT space, in the application space, and still we are behind when it comes to the IoT space. Now, these are just general information, but now how Sternum can help. So Sternum is a universal on-device platform for embedded systems. And we provide 3 key elements. First, embedded security. We make devices secure by design by applying real-time protections into the firmware, into the software. It's embedded inside. It's a full endpoint protection, and it runs on real-time operating systems as well as bare metal, as well as Linux systems. It will help you prevent attacks in real time and alert you if something bad happens. We will dive into it in a moment. The second element is real-time observability. You can get granular device-level visibility of every element in your software. Logs, metrics, events. We have a C-only lightweight SDK that is portable to every system. You can get started in 1 hour. So our customers are embedding the SDK, and within a few hours, they have full observability platform on their real-time operating system device, including third parties within the device. Lastly, gathering the data and seeing it in a visual way is nice, but the real challenge is to generate insights. Sternum provides an anomaly detection engine that is actually self-learning the data that you chose to collect. By learning about your data, we alert you on malicious behaviors, abnormal crashes, abnormal CPU values, and everything that you can imagine that is out of the original pattern of the device. This can actually streamline root cause analysis and speed up debugging, understanding what's wrong, and so on. Now we will take a quick look into the security aspect of our platform. In a nutshell, those of you who knows what RASP is, runtime application self-protection, it's a way to make software self-protected. It is very common in Linux kernel, Windows kernel, providing memory protection, providing elements that makes exploitation harder. Our security makes sure to put integrity verification checks around and inside your software to provide runtime protection. It is agentless, therefore it is very low overhead, less than 3% as NXP tested. It mitigates known and zero-day threats in real time. It protects all of the third parties. If there is an attack attempt that we prevented or detected, you have the live attack information, including all elements in the attack, IP addresses, who attacked you, what happened before and after, what areas in the memory are vulnerable. If you have a memory leak, an information leak bug, we will alert you on that as well. It seamlessly works with both Linux and RTOS, and we have a very smooth CI/CD and IDE integration. Don't worry if you're asking yourself how they do that, how is this thing even working. We have a really elaborated demo to walk you through exactly how it works. But just the high level of how we actually prevent attacks. So Sternum, instead of focusing on vulnerabilities, what we invented is the exploitation fingerprint. Basically, it's asking when there is an attack, how the exploitation itself looks like. So let's take a memory attack, for example. You can see here that memory override is listed here. And Stella mentioned many of the vulnerabilities are memory-based vulnerabilities. Heap overflow, use after free, double free. But preventing all of them, it's almost impossible. But if you ask yourself, okay, I have a memory vulnerability, how the attacker is going to exploit it? Then you realize that in order to exploit a heap overflow, you have to overflow the memory. There is no way that you can exploit a device without overflowing the memory. What Sternum is doing is focusing on profiling the memory in real time and preventing any overflows from happening, any corruptions from happening. By doing that, we can alert you on potential issues early in the development lifecycle, but also prevent 0 days from being exploited or unpatched vulnerabilities from being exploited in real time. That is just one layer of our security. We have an additional layer that keeps the execution flow intact, making sure that no code is running from the memory, no code is running from unallowed sectors, and so on. And lastly, we have a layer that provides malware detection. So we detect if your devices suddenly communicate with unknown IP addresses, or someone is trying to steal the passwords on your device, or there is a brute force attack attempt on your device. These are logical vulnerabilities that we identify using our anomaly detection and visibility platform. Altogether, it's really an end-to-end solution that can obviously bring a level of security that never seen before in the IoT space. Now, let's take the same example and imagine that Sternum is inside. So what we see here is that we're using the same vulnerability. Nothing has changed, but now this device is protected with Sternum. No reaction is required. The overflow has been prevented on device autonomously with no internet connection, with no cloud that needs to be involved. Notification has been sent, forensics has been shared. You will see this in the demo. Plus, and this is an important element, we can alert your enterprise customers of the attempted attack attempt. This is a very simple API integration, and your customers can get the alert directly to their SIEM, XDR, or any other solution. Now, instead of being a potential breach to the enterprise, you are providing a management console that helps them view the cybersecurity health of your products. And this is a potential added services for you as a company. Observability seen inside the black box. I will run really quickly on that to leave enough time to the demo. But as I mentioned, we have a very simple SDK. You can implement it into every platform. It works for Zephyr, FreeRTOS, Microion, VxWorks, and everything that you can imagine. And all the data that you are collecting and defining is automatically synchronizing with the Sternum cloud. Anomaly detection is activated directly on this data. The kind of things that you can collect includes user interactions with the device, errors, logs, and debug information, battery health, resource consumption, temperature, pressure, loop time for critical functions, which could be really valuable. And of course, working with Sternum, you get a full list of recommendations, what you should be collecting. And now our anomaly detection is putting an extra set on eyes on those data that you defined for your product. Now we automatically can alert you of lost communications issues, on patterns that are being violated, on high pressure, or on any kind of abnormal behaviors that you can imagine. This is, of course, helps you preemptive detection of emergent quality issues and even deeply understand the root cause analysis of the bug. Now, when it all comes together, I want to give you a use case from our customer, one of them. So during development, they use Sternum, and suddenly they uncover a few security flaws and code vulnerabilities. Specifically, it was a memory leak and a vulnerability in a Bluetooth library. This was only was found using our dynamic profile feature during development and design of the product. Not to mention the rich information they got from our platform about different elements in their software. Post-market, they had an issue of disconnections between their device and mobile application. Using Sternum and device-level data, they were able to quickly resolve it and access to live device information in the field. Lastly, they saved around 50% of workload reduction due to less patchwork, freeing up developer resources. Imagine the last vulnerabilities we've seen, Ripple 20, Blueburn, all of them was prevented automatically and natively by Sternum. By the way, I invite you to read our blog post about the recent SSL vulnerability, which we have prevented also natively and automatically, putting our customers in a safe place without requiring any patch. More than 6 million annual cost saving on fewer CAPAs and support issues that were solved, and of course, faster time to market due to speeding up debugging processes. To summarize, Sternum helps improve product performance, quality, and security in one platform that combines different elements, that takes you from building the device by spotting security gaps, use granular device level insights to resolve issues and to improve engineering velocity. And we will show you some use cases of that in the demo, and makes third-party libraries safer to use. When you deploy, we simplify the deployment and management of those devices. Device IDs are being generated automatically. Fleet level management and device management is automatically deployed with your device profile. We can catch emerging issues using our AI-powered anomaly detection system, issues in your deployment, in software updates, in crashes and reboots, and so on, and speeding up remote debugging and post-market surveillance. Lastly, we help you innovate by helping you focus the resources on development instead of patch management. We help you generate insights from the existing devices in the field to help inform future design choices and even business development elements. And we make device security tangible for your customers, for your enterprises. We provide continuous monitoring of the cyber health of the device with real-time alerts on any potential attack attempts that make security not just something that you need to prove that you are doing, but something that is tangible, touchable, and can be seen on a cloud platform. Now, thank you very much. I will pass quickly to Lian, our CTO, that will present a really cool demo of how Sternum works on NXP products, and we'll show you our platform, including the device deep level information and some real attack attempts.
Thank you, Natalie. My name is Lian. I'm the co-founder and CTO of Sternum. Today I'm going to demonstrate to you how we integrate Sternum EAV into an existing solution, how we collect traces and send them to ADS, and how the Sternum prevention security mechanism works. So let's start with the integration. To integrate Sternum observability and runtime protection that will protect your entire firmware, including your third parties, you need to follow 3 simple steps. The first step would be to include the Sternum utility library. You can see it here. Second step is to import the Sternum out-of-the-box port files that are suited for your specific RTOS in your system. And the final step is to actually trigger EAV to run and protect your firmware once your build is finished. We are doing it here as a post-build step. You can see it right away. Once we do it, the project will be protected once you click build. And that's it. Now let's increase the observability that we have into the device. We start by adding a trace in this area of code, where the code is determining that a Wi-Fi connection is in progress. So to add the trace, we'll use the Sternum ADS API. So this is the API, you just invoke it, but now we want to indicate what event is going on. So we will go into the SDK utility, and in this utility we can create new types of events that we want to report. For example, we will create a new event that's called Wi-Fi connection in progress. Okay. Now, what the utility did, it defined this event in ADS, in the cloud platform itself, but also defined it in the project. So now our encoding, which allows optimized data to be sent over the internet, get in action. So let's try to use the event we just created. Wi-Fi connection in progress. Okay, now let's build it. Okay, now I'm going to flash the firmware to the board. Okay, let's reboot the board. Okay, now we can go to ADS, go to the device inventory, and we can see that our device is communicating with ADS. I'm going to click on it. Let's click show data, and now we are seeing the device is booted. We see tasks being opened on the device. We see the priority, the stack size, but we also see the event what we just did. And right after that, we can see the SSID that we connected to, the IP address that we got, and more information about the device. So this information is very useful. You can use it to debug. You can send errors that are generated in your device, and that will be collected in your entire fleet. You can collect metrics like CPU usage, chip usage. You can check what is the battery usage. You can check how fast it's depleting. You can calculate your average time that the device takes to connect to a Wi-Fi network. So you can gain any type of analytics and any type of observability and deep observability into your entire fleet, but also zoom in into the specific device as well. Now let's deep dive into ADS in general. On the device inventory page, you can see our entire fleet of devices of all types. You can manage multiple types of devices. For example, here we have the LPC5500 but we also have IP camera that we manage. So you have different product lines, all being automatically managed in ADS. If you want to get general analytics and define your own metrics to continuously monitor, you can go into the glances page. Here you can define any glance and you can monitor any metric that you would like and you collect from the device. For example, let's take a look on the top SSIDs in use. Here you can see the top SSIDs in use. We just go into the Wi-Fi connected trace and then group by it by the SSID. So now we get the most used SSIDs. If we query for the last year, we will see multiple SSIDs in use. So you can understand which one is the most common. But that's only one example. If we'll go into the CPU metric, we can see that we are calculating the maximum CPU usage that was reported to ADS. So we can see how hard we stretch our device. You can also define multiple views of multiple dashboards. For example, let's go into the IP camera dashboard. Here we see the completely different information about the geographic allocation of update requests, general activity over time. We can see also the top IP addresses that the client connected to, and we can continuously monitor more and more metrics, and we can add more and more custom traces and to improve our observability on every iteration, on every firmware release, and also just during integration, adding more and more trace, since this process is so simple. Okay, so we covered ADS briefly. Now I want to show you how Sternum runtime protection works. Let's get back to the project. So we added a couple of special MQTT commands to this project. These commands can be triggered remotely, since the device gets the MQTT commands from the MQTT broker that is hosted on AWS. Let's go over on these MQTT commands that we added. In this example, we added a special command that, given a certain payload, the command execution will overflow the stack memory of the device. So what we are going to do on an unprotected device, we are going to send a special payload into that command, and we will see how we perform a DOS attack on this device, and it will stop functioning. Let's do that now. First, I'm going to flush the unprotected femur into the device. Okay, let's reboot the device. You can see the serial output here. While it's initializing, on the right side, we have the attack console. So we have a Python script that will send the special MQTT command with a crafted payload that will exploit the vulnerability inside the device and cause a denial of service attack. Okay, we can send it now. You see the special MQTT commands being sent to the device, and you can see them received in the device, but now the device is completely stuck and unresponsive. Now we are going to attack the protected femur. So let's flush the protected femur. Go over the same process. Choosing the protected femur, which is automatically created. Okay. Let's reboot the device. Okay, so the device is booted. Now we're going to attack the same femur, the same vulnerable code is inside the femur. Same exploitation, only now Sternum runtime protection is deployed. Let's run this attack script. Okay, so you can see the special MQTT command was received, but now instead of a denial of service attack being executed, a custom user callback is being initiated, and this callback is printing that there was a security alert and the user decided to reboot the device. The user, I mean developer. So the device now boots into a regular state, known state. It is fully functional. You can see it is reconnected to the MQTT broker and completely protected from the attack. So let's see the attack in ADS. Okay, so we are seeing a new alert here and also a new record in the alert list. Let's investigate. Okay, so we see that our runtime protection reported and prevented a stack corruption attack. We also get the memory address that was corrupted and the originating code address, meaning that we can show you the exact function that the attack originated from. So basically, we do not detect vulnerabilities, but when we detect and prevent an exploitation, we can guide you to which vulnerable code was used in the attack. So you see all of that here. So you can use this information to patch 0-day vulnerabilities. Other than that, you get a timeline of events. So you can actually understand what happened right prior to the attack. So we see a special MTTR command being received in the device, and right after that we see the stack corruption. If we go back a little bit in the timeline, we see which MTTR broker we connected to and which Wi-Fi network we are also connected to. So that's a lot of information that will allow you to understand what was the layout of the attack, how it happened. And we also see the special trace that we added in the beginning of the demo, the Wi-Fi connection in progress. Okay, so we explored the Sternum observability and explored the Sternum runtime protection. Thank you for the time. Any questions?
Okay, so thank you to our presenters for all the good information. Now I'm going to hand the microphone over to Marty from Sternum to read out a couple of questions, although we are short on time. So Marty, I guess pick your best ones and we'll follow up with everyone offline for the ones that we're unable to get to.
Great. Well, thank you so much, Rachel. Some great questions. I think a good first one is, how do we connect with Sternum to do a POC? And so the best way to connect would be through nxp@sternumiot.com. Those emails will come to us. I'm happy to arrange that. We'll send that out in an email as well. Natalie and Leon, this one's for you. How does Sternum help if you're already using TPM or SE as an example?
Yeah, that's a question we get a lot. So TPM or SE are super important to store secrets and have secure elements running, but Sternum protects the overall potential for software vulnerabilities in both the application processor and the trust zone or TPM. What it means is that there is an API between the TPM or SE and the application processor, and APIs can contain software vulnerabilities, and this is exactly the way to also steal secrets from TPM or SE. So one way we help is actually making sure that the secure elements remain secure, that there are no software vulnerabilities that can bypass those protections, those hardware protections. The second way that Sternum helps is the fact that you're using TPM doesn't mean that you don't have software vulnerabilities in your application. So basically, imagine your Bluetooth library. It can have a heap overflow that can lead to remote code execution and someone taking over your device. Maybe you won't be able to steal secrets from the TPM, but this is still not a very desired scenario. So Sternum actually helps do that, protect the entire device, the entire software running on the device, and the entire libraries running on the device. So it's actually complementary to any secure elements that you have. And this is also the reason why NXP and Sternum partnered. It's a layer of hardware security and a layer of software security being on top of it.
Great, thank you. A question about regulatory requirements. So how can EID help customers with regulatory requirements for vulnerability mitigation?
Yes, so regulatory requirements are a bit different for each industry, and we help with to a few industries in multiple ways. So for example, in the medical device space, we help to automatically put a check mark over post-market surveillance, over incident response, over the requirement to be alerted of potential breaches, and on patch management, which is a key element that we help with. It's the same for industrial regulations and also the new IoT consumer label. So a few elements requires monitoring, requires applying with certain levels of security, and requires incident response and patch management. All of them are covered automatically by our platform.
Great. Well, I have time maybe for one more question. So is a free demo version available? And so I can answer that. We do have a open WRT free version for 3 devices available on the Sternum website, sternumiot.com. We'll also send that out with the answers, but yes, you can test this on a open WRT platform. So I think that's all we have time for. I'll turn it back to you, Rachel.
Wonderful. Okay, well, once again, thank you so much to our presenters for preparing this material and for being here to present. And thank you to our attendees who joined us today. We will be following up with you to send you the recording, the information about how to view this on demand. And we hope to hear from you if you have any questions. Thanks for joining us today. Goodbye, everyone.
Thank you very much. Bye, everyone.
Thank you. Bye-bye.